So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says flatten a linked list. The problem goes like, given a linked list containing n head nodes, where every node in the linked list contains two pointer, next and bottom. Next points to the next node in the list, and bottom points to the sub linked list where the current node is head. Each of the sublinked list node and the head nodes are sorted in ascending order based on their data. Now flatten the linked list such that all the nodes appear in a single level while maintaining the sorted order. Note the below pointer is represents the bottom pointer and the right pointer represents the next pointer. The flattened list will be printed using the bottom pointer instead of next pointer. So this is interesting. We have such kind of list over here in an example, which is pretty sure that we are having for a node next and bottom. So it's very good for us that we are not having next is also not having bottoms are not having any next pointers, else that would be a complete new challenge. So we have such kind of thing. When we merge this one, everything should come to bottom. So if we have 5, 7, 8, we can take 10 and append it below 10, and then should go 19, then 20, which is correct, 19, 20, and then 22. In such a way we should go ahead. But the idea here is to merge next and bottom. These are the constraints, and expected time complexity is n into m. So we have a good amount of size, although it says that we can use O of n auxiliary space. Let's see we can avoid that as well, if possible. So yeah, we are having linked list of such a kind that here we have like A, we have bottom like this, B, C, we have D, and something like E and here F. How can we do it? Let's break this down problem a bit to understand that hey, can we do it or not? So if I wanted to merge A, the list just below A and the list below D, it should be very simple for me to do it, right? So for that I'll just clean the list D first, and then I'll go ahead and assign. So cleaning the list D means I should not have anything here. So it should be null, and E and post E I can have F, which I mentioned null over there. So now once I'm sure that hey, the next list or next pointer is clear, then my problem is simpler. Cool. At least we have simplified the problem now, and we can solve these two problems. Now how can we solve these two problems? We have A pointer and we have the next pointer. I'll tell it as capital A and I'll call it as capital D. Now I guess it's a classic problem to merge linked list A and linked list B. Instead of next pointers, I just wanted to iterate the bottom pointers. So merging the linked list is not so very complex thing. So once we merge the linked list, what do we want it to do? So merge the linked list with bottom pointers, then what? Return the resulted list. So if we go ahead and if we merge this linked list, what will happen is we'll get a list, let's say A, and then we have compare B and D. Because A is already done from the picture, I'll just remove A. Now we have B and we have D. These are 2 pointers I'm running through. So A is done, I'll just mark A as dot. My pointer was here and this pointer was here. I have marked it, used it, my pointer goes to here. So within B and D I have B. Next I have used B, so I'll just mark it as used. Increment the pointer to star. C, have C, cool. Then I've go ahead and mark D, and I've used D, E, F, and you got the drill now. So in this way I can go ahead, and once it is done, what I wanted to do is I just wanted to return the first pointer. Yeah, that's what I wanted to do. First pointer in this case is A, and returning A would make sense. Cool. Let's summarize this once again. We have a linked list of such kind. Let's take this example. We just wanted to focus on the last part first of all and merge the list below 19 and the list below 28. If we are done with that, we can go with the list below 19 and below 10, so that our problem is much more simpler. Next, if our problem is much simpler and we have solved that problem, we need to go ahead and merge the list from bottom pointers and return this. We have already merged. Cool. And we need to do it repetitively till we are at this position. So I need to repetitively flatten the linked list and then merge. Nice. So which brings me to the point that, hey, if root is equal to null, I'll just return null. Or for that matter, or root.next is equal to null. Because we don't have any next, so itself is an answer. I can return the root. But in case if that is not the case, I want to simplify the next nodes. Remember, we have had a point. Next pointers needs to be clear. Simplify the nodes, that means flatten the nodes first. So I'll use the same function because this function is responsible to flatten the node. Don't forget, function responsible to flatten the node. So I'll use the function responsible to flatten the node, and guess what? Flatten is a function. What node I need to simplify? Again, I want to simplify next nodes. So root.next. Again, this will give me a clean next node. So where clean next node is equal to, I'm using broad names because it would be much more simpler. Cool. This problem is solved. I'll mark it as solved. Solved. Next, merge the list with the bottom pointers. Cool. What I'll do, I will have merge method, which would be responsible to merge. What do I want it to merge? The bottom pointers of both the list. What both the list? My current root and my clean next node. Cool. Once I merge it, what should I do? Return the result list. Cool. I'll return the result list. Let's complete the merge function as we have discussed how merge would go ahead. So this is merge. It will return node. It will have two nodes A. I'll take small a and node B. It's very similar what I mentioned it over here. I'll have two lists, A and B, and I would be what do I say? Like I would be merging them one by one. And now merging would go as per merging would go as per the ascending order. That means if a.data, or in case let's check, if a is equal to null, then obviously a is null, I cannot return a, so let's return b then. But what if b is also equal to null? So I'll return a. And if both are null, just return null, man. What difference would it make? So if a.data is less than b.data, that means a is small, so choose a, else choose b. What do I mean by choose a? I mean that I wanted to choose a, that means a.next I wanted to choose, and b with b. I will not increment b pointer because I have not chosen B, and here I have chosen B. I will increment B pointer because I have chosen it. Now that means choose A, that means A dot next is equal to merged list. Now what does it mean? I am at this pointer right now. Let's me rewind some points again. So I have B, I have A. Let's take here D and here C. So I have changed the list again for a while, just for understanding sake. So 2 pointers are here. Now tell me A and C, between A and C, what is small? A is small, so I'll choose A. Next I wanted to do what? I wanted to merge not this but this pointer. You see B and C. So merge A dot next. It's a capital A, man. It's a capital A, right? Or I'll tell it X or Y. That would be much more simpler. So it's capital X dot next and Y, because I have chosen A and I wanted to choose X dot next because I have already have A. Why should I go ahead and repeat A itself? I would take next of A or bottom of A. So bottom of A, not next. My bad. It's not next. It's bottom. Bottom. Yeah. Bottom. Because I wanted to merge with respect to bottom, right? Not next. As this is mentioned within the problem statement itself, using bottom pointers. Now I'm merging X dot bottom and Y. It would return me something. It would return me what? A merged list. Consider this, that I'm breaking this list in such a way. The function is getting this and this, X and Y. Now what should happen? A has 2 pointers to us. Where should I append this? Because there would be a result of this, right? There would be a result, and the result of this list needs to be assigned to A, because A cannot live independently. Neither this list can be independent. They need to be linked. So A is used here with a bottom pointer. That is the reason A dot bottom is equal to merged list from A dot bottom and B. So merged list from A dot bottom, which is this, and B. And likewise I'll also do that. B dot bottom is equal to merged list of A and B, and ultimately I'll return the result. Wait a second, what result do I have? So I don't have result variable. I'll just use node result, and result would be the minimum one. So result is equal to A if it is A is minimum, and result is equal to B if B is minimum. That's cool. And ultimately I'll return this result. This result means it's a merged list, flattened merged list, and that is what we are returning from here. And cool, I guess there are no rest of the steps remaining. Can we compile this? Yes, let's compile this one to check. Okay, it has passed the sample test cases. Let me submit this problem for rest of the test cases as well. And yeah, it looks like it's all passed all the rest of the test cases. It was a classic problem. It was still a simpler problem. Why? Because we just had a bottom only with bottom lists. If consider, just take in your mind, if 7 can have a next pointer which would be pointing to 14. Now in that case, how would you deal with this solution? Will this current solution be working in that case or not? So think about that self, and for more such linked list related content, click the video on your right, and I'll see you in the next one.